So in order to find missing side lengths of right triangles, I could have been more specific. It'd be finding missing side lengths of right triangles that are created from an altitude drawn from the right angle of a triangle. But that's what each of the theorems deal with. But I could set up a grid, or it's like a tic-tac-toe grid, where along one of the sides of your tic-tac-toe grid, you're putting the side lengths. So you have each of the three types of triangles. You have the small right triangle, the large right triangle, and then the medium right triangle. So small, medium, and large, those are the right triangles. Let me just draw a diagram or an example. So we started off with our right triangle there. We drew the altitude from the right angle, and all three of those triangles are similar. This right here is the small right triangle. That's the smallest one. This one here is the medium one. The original one is always going to be the largest right triangle. And then in each of the right triangles there, we have the short leg, or I'm going to abbreviate that SL. We have the long leg, or LL. And then finally we have the hypotenuse, or just H. But to solve problems, we could use this grid, and then any part of the grid, so like a corner. Once we actually do start filling this out with specific numbers or possibly unknowns, like this corner would give you a proportion to set up. Lower right corner, upper right corner, lower left corner, or the four corners. Since you have a proportion and then there's four parts, basically any of the parts of the grid would give you a proportion. And then we'll take a look at some examples specifically using this grid. But using this grid for most people seems to be a lot easier than trying to apply the theorems, even though in reality, if you're using this grid, you're applying the theorems that we just covered.